Hello everyone, welcome to Chemoholics, your one-stop channel to make chemistry simple, easy and exam ready. I'm continuing on my video series on solving the numerical problems on analytical chemistry, part A of paper 3rd, which come in paper 2018 examination of the Geochemist exam. And here today I have taken two problems from the paper of 2018 and each question is of 5 marks. So here is the first question for today's video. uh, 0.4 gram of an alloy was analyzed for nickel by gravimetrical method using dimethyl glyoxime reagent. Okay, so this is the structure of dimethyl glyoxime. You know the oxime, right? So this is the oxime reagent. The weight of nickel as glyoximate, okay, this is the glyoximate here, after washing and dry comes to an constant weight of 0.285 gram. Okay, after this reaction, whatever amount of, this is for example, this is the amount of nickel which is X in 0.4 gram of alloy. Okay, in 0.4 gram of alloy, X amount of nickel is there, and this X amount of nickel is reacting with this dimethyl glyoxime to give this glyoximate. Here actually what happening here, glyoximate, they are saying that glyoximate, that means this hydrogen is removed from here, which gives a negative sign here. So this glyoximate ion is formed by whatever amount of this nickel is present in this alloy. So after reacting with nickel, it has formed a nickel DMG complex. So this is the structure of this complex, and the amount of this complex is given here is 0.285 gram. What we need to calculate is calculate the percentage of nickel in the alloy. Okay, so let's say amount of nickel plus 2 in alloy is X gram, right? And we need to calculate the percentage of this, percentage of nickel. So how we are going to calculate is X divided by 0.4 multiplied by 100. Okay, so if we were able to calculate the amount of X, then we will able to calculate the percentage of this nickel. Now how we are going to calculate the amount of this nickel? Here they have also given a hint that this nickel glyoximate has a molecular mass of 290.93 gram. It's molar mass, right? So let's say here this a single complex has only one nickel. So how we are going to solve it? 290.93 gram of complex will give you 58.69 gram of nickel plus 2. But we don't have this much of amount, we only have this much of amount. So 285 gram, 0.285 gram of complex will give 58.69 divided by 290.93 multiplied by 0.285 gram of nickel. So if you solve it, you will find this value as 0.0575 gram of nickel. Okay, so this is the value of what? This is the value of X. Now when we put this value in X, 0.0575 divided by 0.440 multiplied by 100, it will give you 14.37 percentage. So this is how you need to solve this question. Okay, I hope you understand this question. Now let's move to the next question of the series. An ore was analyzed for manganese content by converting the manganese to Mn₃O₄ and by weighing. Okay, if a 1.52 gram of sample yields Mn₃O₄ of weighing 1.126 gram, what is the percentage of Mn₂O₃? Okay, basically what they are saying here, they have started with the mass of an ore. Mass of ore is equals to, they already given it 1.52 gram. Okay, and somehow they are converting the manganese into Mn₃O₄. So amount of Mn₃O₄ is equals to, in this 1.52 gram is only 1.26 gram. Okay, and what they are asking, the question is percentage of Mn₂O₃ in the ore. That is the question that they are asking, right? So here we need to assume that this Mn₃O₄ is actually composite of MnO and Mn₂O₃. So here, if this 1 mole of Mn₃O₄ is there, then we will get 1 mole of Mn₂O₃. Okay, but we need this in gram. So how we are going to calculate? The mass of 1 mole of this Mn₃O₄ is 228.82 gram. Mn₃O₄ will give you 157.88 gram of Mn₂O₃. Okay, but we have only how much amount of Mn₃O₄ we have? We have 0.126. So 0.126 gram of Mn₃O₄ will give you 157.88 divided by 228.82 multiplied by 0.126 gram of Mn₂O₃, and if you calculate it, you will find it out as 0.087 gram is there. Okay, so half of the question is solved. Now what they are actually asking, they are asking the percentage with respect to the ore. Okay, this is the question. So how we are going to solve this? Percentage of Mn₂O₃ is equals to, this is the amount 0.087 and the amount of total ore 1.52 multiplied by 100, and if you solve this, the question the answer is like 5.72%. Okay, so this is how you need to solve this question. So basically here they have confused you by doing this. They are giving Mn₃O₄ and asking about Mn₂O₃. So that's how you need to solve this problem. I hope you are able to understand these two problems from 2018's paper, and thank you so much for watching. And if you enjoy this video, please do not forget to like, comment, subscribe and share. Thank you so much.